Adam Ralph, who's working for Particular, builders of, amongst others, the End Service Bus software. He will take us on a session that will explain how you can deal with code that will execute in the future, how it will be maintainable from today's perspective. So let's get started with the first session of the day, how to make the code for tomorrow's code look like today's code. Enjoy the session and see you afterwards for questions. Feel free to post them in the Discord channel. Enjoy.
Good morning, everyone. It's great to be speaking to you all over there in the Ukraine. I've been following events very closely in the Ukraine, so I think it's absolutely fantastic that the organizers have managed to make this happen, and I'm really happy to be able to talk to you. My name's Adam. I come from the UK originally. I live in Switzerland these days, but right now I happen to be in Portugal. So I am a fully 100% remote worker, so I like to make use of that. And I work for a company called Particular Software. We're the makers of a product called End Service Bus. I will talk a little bit about that today because it does demonstrate some of the concepts that I'm going to talk about today. Now I am going to attempt to kind of mess with your mind a little bit and introduce some ideas you may have not seen before. And I'm going to talk about a class of problems which not many people talk about too often. They have to do with the runtime behavior of your code. You might think that's a little bit strange. You must have thought about the runtime behavior of your code in the past when you've been writing code. But there are a certain class of problems which only really manifest themselves at runtime. Very difficult to predict, very difficult to test for, and they are chiefly to do with the arrow of time. So this is what this is the consideration of what happens in your code today versus what's going to happen in your code tomorrow. So I will go into more detail if this doesn't make sense yet. I'm going to probably turn around some ideas you've already had and turn them upside down and invert some things completely. And I do expect that to raise questions. So if you do have questions, please don't hesitate to ask. I don't know if we'll have time for a live Q&A because I've got a lot of material to cover and we've only got 45 minutes. But I will be available online after the talk. I think we're going to be on Discord. So I'll do my best to answer any questions you have, and I really look forward to that as well. So I'm going to talk about Amazon. I'm going to use Amazon as an example because even if you don't have Amazon in the Ukraine, I'm not sure if you do. In fact, we don't have Amazon in Switzerland, but I do use the German Amazon site sometimes and the UK Amazon site. Sometimes they do ship some things to Switzerland. But I'm sure you've all seen some kind of online e-commerce website until now, where you order things online and you get them delivered. Now, the thing about Amazon is if you're going to create some kind of e-commerce website, your main competition these days really is Amazon. So you need to differentiate yourself somehow. So, for example, your business might come along, your domain experts, your business users, and they might say, well, in order to differentiate ourselves, we're going to order discounting for people that order at least some certain amount of goods each week. So they might say, well, if someone orders $100 of goods within 1 week, we're going to give them a 10% discount. So you say, right, easy, we're going to get this done. And we're going to use all the wonderful methods we're familiar with, like DDD and object-oriented design and event-driven architecture and test-driven and whatever else. Pretty much like I've tried to use every animation in this slide. And that's all wonderful. You get it working, and you might write some code like this. So let's just examine this code quickly. So what we're saying here is when we submit an order, we're going to look through all the orders we have. We're going to match the order's customer ID to the customer ID of the orders we found. So in other words, we're going to query all the orders for this customer. We're going to look back at all the orders which are greater than or equal to today minus 7 days. And we're going to total that, right? So simply put, we're going to take all the orders for this customer over the last week and add them together to find out the total. And if that week's total for that customer is greater than or equal to $100, let's say, we're going to give a 10% discount. Otherwise, we give a 0% discount. And then we do all the rest of the stuff we need to do to complete that order. Now, this code looks great. You've test driven it. You might do this using messages. It's all nice, clean code, and it goes to production. And what's so bad? Well, first of all, before we get into a specific problem, this could potentially put some considerable database load on your system. So we're querying all orders, we're matching the customer ID, we're looking at the timestamps. So, you know, it's really important to get your database indexes right and that kind of thing. But even if you do that, if you've got lots and lots and lots of orders coming in, this could put considerable database load. But you may be able to optimize that away. But there's another consideration here. So think about a user versus an account. So when someone's ordering something on Amazon, it isn't necessarily one person using that account. Well, think about a corporate account. You may have a corporate account for your company, and 2 people in the office might be using that account to order something on your e-commerce website at the same time. So effectively, what you have are 2 threads going in and looking at the database, querying all the current orders, all the orders for the last week for this customer, and they both see, oh, this customer's ordered $90 worth of goods so far this week. So what's going to happen? How much discount are each of these 2 orders going to get? They're both going to get 0, right? Let's say they're both 10 or $20. Each one of the orders takes a total up to 110, right? So if you look at that week, one of these orders should take that total to above 100, and the other one should get discounted. But they're not doing, that's not happening. Both these orders are getting discounted at 0 because they're both seeing that the total is 90. So what happens then is you're effectively penalizing your users for clicking too quickly. And then the person who pays the bill at the end of the month, your customer, might come to you and say, hang on a minute, we ordered $110 worth of goods this week. Why aren't we getting our 10% discount on that last order of $10? Okay, it's only $1 in this case, but it could be a lot more. And you say, something's wrong here. And you go back to your tests. You say, no, everything looks fine. Like we're doing the right thing here. You run the tests and everything works fine. You think, well, what on earth is happening here? I can see it. Yeah, you're right. We didn't give you a discount. Then you spend some time going into your logs and you have a look at, and hopefully you've got good enough logging that you can kind of tell what happened. And then after a while, you've been looking at this for a couple of hours and you realize, oh no, I know what's happened here. We've got a race condition. It looks like 2 users ordered at almost exactly the same time. And I think what happened is both of these threads read a total of 90. So you go back to the customer and you say, yeah, you know what? I found out what happened. Your use clicked too quickly. And they'll say, what do you mean they clicked too quickly? Well, if you make 2 orders more or less at the same time, our system's not really designed for that. So next time, make 1 order, wait until you got the confirmation, then make the other order. And the customer will say, well, we've got hundreds of people using this corporate account. How on earth am I going to enforce that? And then you say, well, I don't know. You come up with crazy ideas like, hold up a sign in the office to say I'm ordering, or just shout across the room. And you know what the customer's going to say at that stage? I think I may have to go to Amazon instead. Right? And this is what happens, right? I don't know if you've heard the phrase death by Amazon. This is what tends to happen with businesses that don't run their things efficiently and well enough. You end up getting killed by Amazon. So you think, okay, well, look, I know how we can solve this. We're not going to make that ridiculous suggestion to the customer. We're going to wrap each of these things in a transaction, right? Because that ensures that everything that's happening in one thread will be happening atomically, and you won't be able to do something to that same data at the same time in some other thread. So you wrap both of these in transactions, you switch that on, you roll it out into production, and all of a sudden your error logs fill up, right? Deadlocks everywhere. So you say, oh my God, what have we done? Quickly switch that transaction thing off. But what you have to realize is that those errors, they're actually giving you feedback. They are telling you you have race conditions and concurrency problems in your system. So you think, okay, transactions are not going to do this for us. I know, we're going to write a batch job. I've done this before. This works really, really well. We're going to write a batch job that runs overnight, and it's going to do something like this. We're going to go through each customer. We're going to find all the orders for that customer in the last week. We're going to sum them up. And if that sum is greater than or equal to 100, we're going to apply a customer discount of 10. Otherwise, we're going to apply a customer discount of 0. Now, there is, again, one glaring problem with this, which you may have already spotted, but I'm going to investigate some others first. The thing is, if you're lucky, you get to write that batch job in C#. But whatever you do, I'll give you this as a tip from experience, do not show that to your DBA. You know why? They'll rewrite it in SQL. They rewrite it in SQL, and all of a sudden, all your nice domain-driven aggregate routes and all the rest of it here are kind of being bypassed, and you've got this other SQL thing tacked on going straight into your database. And you know what? This is very, very hard to argue against, because although what we're doing in this stored proc and the C# you saw before is quite simple, things aren't usually that simple, right? Business rules tend to be a lot more complex. And a DBA is almost always going to be able to make stored proc that they write for this batch job execute faster and more efficiently than your C#. DBAs are very good at this. They put indexes on tables, they optimize queries, they add hints to the query plan, and they can make this stuff run really well. And what will often happen is they'll write the first version of this and then give it to you for maintenance. You know what tends to happen then? Another one appears. Because that one's working so well, this other one appears. Another one appears. Another one appears. And all of a sudden, this stuff in the middle here, your nice domain-driven design, test-driven development, object-oriented, event-driven architecture, whatever it is, starts to kind of shrink in significance, right? The real system ends up being out here. And you find that these stored procs are the way that you start to address, sorry, I clicked the wrong place. These stored procs are starting to become the place where all your new business requirements are implemented. And it's almost like a strangler pattern. So I don't know if you're familiar with the strangler pattern. This is where you take a nice piece of code in the middle, this is where you take a horrible piece of code, like a big ball of mud, and you carve bits out into nice code, and you strangle that thing in the middle. This is like the reverse of that. You've got this nice, lovely code in the middle here. You're slicing parts out and replacing it with this great big bunch of SQL out here. And this is just random SQL, by the way. It doesn't mean anything. And you're strangling that nice stuff in the middle. It's like a reverse strangler pattern. And I've got to tell you, this is a horrible place to be in. I've lain awake at night sweating and not being able to sleep, thinking about how I'm going to debug that stored proc tomorrow. And I almost, at one point, I almost said, okay, that's it. I'm becoming a SQL specialist because I spent so much time in that space. So even if we put all of that aside, even if you manage to keep your batch job in C#, there's another big problem here. What happens again if your two users make an order on at the same time, or even on the same day, and they both read 90 from the current week total? Your batch job's not going to run until that night. So they can submit these two orders, and after those two orders have been submitted, the total is 110, and one of those orders should have seen a total of 100. That discount's not going to get applied until tonight when the batch job runs. So you're no longer penalizing users for clicking right next to each other. You're actually saying you must not click on the same day. And again, that customer will say to you, why is one of these orders not getting discounted? Yeah, you know what? Do one order on one day, wait, and do the next order on the second day. They're going to go to Amazon, right? Death by Amazon. You've effectively taken your race condition and extended it by an entire day. You could, of course, extend your batch job to retroactively apply discounts. So let's say the customer sends in a bunch of orders on one day. That night, you look at all the orders, set the discount level, and discount an appropriate amount of orders from the past day, which should have been discounted. Better, but you know what? Amazon does that real time. When you go to Amazon, you see your discount as you're ordering, regardless of who else is ordering at the same time or is ordering at the same day, right? You're on that slippery slope again to death by Amazon. So we need to do better. We need to rethink this arrow of time. So let's have a look at this again. The requirement here is that as orders come in, and they come in during the week, so forth and so forth, when an order comes in, this is a requirement given to you by your business. We want you to look back 1 week. We want to sum the orders together for this customer for this week. And if it's greater than 100 or equal to the 100, give a 10% discount. Now, there's something very important to bear in mind here. What I just described that the customer gave you as a requirement is not a requirement. This is kind of like something I realized, this is an epiphany I had over the past few years, that customers don't give you requirements. When I say customers, I mean your business users. They do not give you requirements. They give you workarounds. And those workarounds are within the constraints of how the current system works and their knowledge of how that system works. The actual requirement is, when an order comes in, if that customer's weekly total of orders is greater than or equal to 100, give a discount. Okay? We're not saying look back, we're not saying sum it together, we're just saying if that customer's total is greater than 100 or equal to 100, give a discount. Now, by throwing away that look back in time and do sums, we're now able to look, instead of looking backwards in time, we can actually kind of look forwards in time. Now, it's not impossible, it is impossible to kind of predict the future, but you can fold things that you want to happen in the future into your code now. If that sounds a bit strange right now, I hope that I'm going to explain it now and you'll understand. We need to rethink this arrow of time. So let's have a look at this again. When the first order comes in, what is the week total? What is the current week total? Right? It's 0. So there's no discount to apply. But what we're going to do is we're going to add this order's total to the week total. And we're going to save that for next time. And this is the important bit. We're going to send a message to ourselves to say, in a week's time, remove that order total from the week total. Okay, so the order that's just come in, its total is only going to be part of the week total for 1 week, because we're adding it now and we're going to take it away in 1 week's time by sending ourselves a message to do that. When the next order comes in, we look at the week total. We've only got order 1 in there, so it's say 50. So we don't give a discount, but we do add the second order's total to our week total. And we send a message to ourselves in a week's time to remove order 2 from that total, which will happen after the removing of order 1. We do the same thing for the next order. We add that to the week total. We send a message in a week later from then to take away that from our total. Then orders come in and they come in, and we do the same thing over and over again for each order. Now, what happens when a given order comes in? What do we do? Do we look back and try and sum up the totals and all that kind of stuff? Or do we just look at the week total? The current week total is saved in the database. It's one number that we have to look up. But the problem is we need a good way to program time. You see, HTTP is no good. How do we send ourselves a message in the future over HTTP? How do we say, oh, hey, HTTP API, I'm gonna send this message to you now, and I want it delivered in a week's time? Doesn't really work so well. System.threading.timer, yeah, that'll work absolutely fine. But what if the process crashes? You restart the process, that timer's gone out of memory, you've lost your message that you want in a week's time. What we need is something else. So this is where I'm going to introduce the concept of a saga. Now, I'm not going to go into sagas in too much detail. If you want to look at exactly how a saga works, you can follow this link. Take a screenshot now or take a photo with your phone and have a look at that later. What I'll very briefly say is a saga is basically a message handler. It handles a message, it does some operations, and it may send some messages out. That's really all it is. But with one key thing, its state is persisted. So what that allows us to do is receive a message in a saga, perform some operations, save our current state, later on, receive another message, wake up the saga, retrieve our state, and perform some operations based on our state and the new message. That's basically a saga in a nutshell. So again, what we want to do here is in our saga, we're going to receive a message. We're going to add that message's total to our week total, right? That is our state. We send ourselves a message in the future to remove that total from our state. And then we save our state to the database. And we do it the same, and we do the same again when every order comes in. We add our total to the week total, save it to the database, 1 week later, take it away. Add it to the total, 1 week later, take it away. Add it to the total, 1 week later, take it away. That's really all we're doing. It's a very, very simple operation. But how do we code this? How does this actually look? Well, let's take a look. So this is a saga, and basically it is just a class. That's all it is. But what we do is we inherit from this saga base class. And that just does some infrastructure stuff with saving the state and that kind of thing. And what we do is we say, well, our state is going to be represented by this discounting data, which is a nested class here. And I know that some people don't like nested classes, and I don't generally, but for the sagas, I think it's a nice way to encapsulate the fact that that state belongs to that saga and it doesn't belong anywhere else. Now, why are we getting red squigglies? Yes, so we're being told we need to tell the infrastructure how to configure, how to find a saga given a message. Now, what we want is discounting per customer, right? Remember that. It's discounting per customer. We want every order that comes in to be associated with a customer so we can work out their discount. So we're telling the infrastructure here that when a submit order message comes in, I'm going to map the customer ID of that message to the customer ID of the Saga. That's all it's telling us. And in our data, we're just storing that customer ID in order to have that matching, and we're storing the week total, right? So very, very simple. A given Saga is for a given customer, and it has a week total. That's the only requirement we have. Then what we say is, well, this Saga is going to be started by a message of the type submit order, right? So whenever a submit order comes in, we want to start a Saga for the customer of that order. And this also means that I will handle future messages of submit order as well. It's almost like saying, I'm started by messages of submit order and I handle future messages of submit order. This is a shorter way of saying that. By inheriting that interface, we have to implement a method in order to handle that message. So what we're saying here is, for a submit order message, we're going to work out a discount first of all. So we look at the current week total. And remember, this would have been altered by previous orders. And we say if it's larger than greater than equal greater than 100, the order discount is 10. Otherwise, the discount is 0. Then we send a message to process that order with that discount. Okay, so by doing that, we're guaranteeing that this order that's just come in will have the correct discount level. Now, here's that tricky stuff, or well, actually pretty simple, but here's the trick in order to store our state. We add our total of the current order to our week total, right? So this order has now increased the week total. And here's the all-important part. We request a timeout. We flow through this context object. Don't worry too much about that now. That's just an infrastructure thing. And we say time span 7 days from now. And we just propagate the same message again because that has all the data we need. So we're saying to the infrastructure, in 7 days' time, deliver this message back to me again so I can do something with it. And what we say then is, well, this Saga implements I handle timeouts of submit order as well. And in the timeout method, we say we take away the total of that order from our week total. Okay, and then we just return a completed task because we've got async tax to pay. Well, I hope you can see here how we've implemented that pattern. We receive our message, we look at the week total, we apply that discount, add the week total, we increment the week total by the current order, we send a message in 1 week to then take away that order's total from the week total, and we're done. So how does that actually work? What does the infrastructure actually do here? Let's take a look. So a message comes into the queue. The bus and service bus in that previous example would dispatch the message into that Saga. And that really just means calling that method with that message. The Saga will look at the discount, send a message to process the order, etc., etc. It will then set the state, which will go into the database, and it will request a timeout, right? This is the message that we're requesting to be delivered in 7 days' time. Now, the bus will now do one of two things. It will either put that message back into the queue, and it will say to the queuing system, deliver this in 7 days' time. And some queuing systems do support this, right? So Azure Service Bus is a good example. Azure Service Bus will actually do this for us. We can just tell it to deliver a message in 7 days' time. And despite its name, Azure Service Bus is not a service bus. It's really just a queuing system. For other queuing systems, that kind of works. I'll go into a bit of detail in a minute, specifically Amazon SQS and RabbitMQ. For other queuing systems, a good example is MSMQ that doesn't work. You can't tell MSMQ to deliver a message in 7 days' time. But what we can do, and this is what the bus will do in that case, it will save that timeout via a persister into the database. It will persist the Saga data. When all of that's done, it will also persist the Saga data at the same time, regardless of which method is used for timeout. And then in this case, it will poll the database to find out when that timeout is due. That's not a nice way to be doing things, really. It's not a nice thing to have to continually poll the database. So we always prefer asking the queuing system to do this work for us when it can do so. I did say I was going to talk a little bit more about Amazon SQS, because this is quite interesting. Amazon SQS only allows us to delay a message by 900 seconds. Okay, which is, my maths right here, 15 minutes. So that works fine if we want to delay a message for 600 seconds or 900 seconds. But if we want a timeout for 2,800 seconds, that gets a bit more tricky. What we have to do is say, first of all, delay this message for 900 seconds, which is the maximum in SQS. And that means we have a remaining timeout that's required of 1,900 seconds. So we put it back into the queue for another 900. That leaves 1,000. We put it back into the queue for another 900. That leaves 100. And then we put it back into the queue for another 100. Right? We do this using message headers to say how much timeout is remaining each time. So by putting it through the queue 4 times like that in Amazon SQS, we simulate a 2,800 second delay. Right, it's fairly simple, but unfortunately, there's overhead of the message being delivered 4 times, or rather, how many times? Yeah, but delivered 4 times and putting it back into the queue 3 of those times. But it does work great. RabbitMQ is a bit more interesting. If we take a closer look, so the thing is about RabbitMQ is you can say to RabbitMQ, put this message in this queue with a time to live of, say, 600 seconds. And what that means is that after 600 seconds, that message will expire, and then you can do something else with it. And that something else could be then, well, put it in this other queue, and the bus will consume the message from that other queue, and then you've simulated a timeout, right? So the original queue, nothing subscribing, you just put it in there and say live for 600 seconds. It expires, you put it into a real queue that something's subscribing to, gets delivered, and you've simulated a timeout. And you can do that with 900 seconds, you can do it 1,500, you can do it with 2,800, it really doesn't matter. But the thing is, you need a time to live setting for a message is per queue. So if you want to do this, you need 1 queue for 600 seconds, another queue for 900 seconds, another queue for 1,500 seconds, another queue for 2,800 seconds. That works fine, but there is a problem because I can request a timeout and I can basically put any number I like in here, right? We can have arbitrary timeouts, or you could be really evil and you can say random timeouts. Now, we could handle this quite easily in NService Bus and say, right, well, whenever you give us a timeout, if we haven't got a queue for that timeout length already, we'll just create one. And then your customer comes back a few months later and says, NService Bus has just created 40,000 queues in my broker. What is going on? And you say, well, you've got too many different timeout periods. And then they'll say, yeah, you know what? I'm not going to look for another solution. So that doesn't really work. So we need to do something more clever. Now, let's have a look at a number, an arbitrary number. I'm going to take 42 because that's one of my favorite numbers. 42 seconds is only written 42 in base 10. But there are other numbering systems we know about. One of them is binary. So in binary, you can write 42 seconds in base 10 as 101,010 seconds in base 2, or binary. Now, what if in RabbitMQ, we create a 32-second queue? Then we create a 16-second queue, then an 8-second queue, then a 4-second queue, a 2-second queue, and a 1-second queue. We can write our 42 seconds in base 10 in base 2 alongside those queues. You see where I'm going with this now? We put the message through the 32-second queue, we skip the 16, we put it through the 8-second queue, we skip the 4, we put it through the 2-second queue, and we skip the 1. And by putting it through the 32, the 8, and the 2, we've simulated a delay of 42 seconds in base 10. We think that's pretty cool. We haven't seen anyone else do this. So it's a nice kind of fusion of business logic and kind of base fundamental computing. And we're quite proud of this. It's quite a neat idea. It's always nice when you apply binary logic to something you're building. So we can use this method to apply arbitrary timeouts of any length. Now, up to 32 seconds, that obviously only gives us a maximum timeout of, what is it, 63 seconds, am I right? However, we do create more than 6 queues, we actually create 28. And that gives us a maximum timeout of 2 to 28 seconds, or that many seconds, or about 8.5 years. Now, you might be thinking, well, why 28 queues? Why 8.5 years? Well, we did think about just giving a maximum timeout of 1 year, first of all, because we thought, well, that's pretty much going to be enough for most business requirements. And then we thought, well, that's actually that would require 25 queues, and 25 is an odd number, so we don't like that. So let's go with 26, which is give us 2 years. And then we thought, well, you know, just to be really safe, let's go 1 order of magnitude higher and make it 2 to 27, which would give us like 4 years or something. And then we thought, well, you know, yeah, 27's odd, so 28's an even number. Let's go with 28. So 28 it was. So it's 8.5 years. We were thinking about going with 32 queues because 32 is the number we like, obviously, as developers. That will give us a maximum timeout of 136 years. It's nice to think that someone will be using N-Service Bus in 136 years, but a little bit far-fetched. So 28 it is. And if anyone ever comes to us and says, well, we really need a 10-year timeout, then we'll add a 29th, and we'll probably add a 30th at the same time, which will give you, well, about 34 years, probably going to be enough. So that all works really well. Now, the thing is, that all sounds fine and lovely. We've got rid of our batch job, but don't we still have the same problem here? Can't people click this at the same time? Are we not going to read the same week total of 90 from these 2 threads and only discount 1? Well, on the face of it, yes, but there is something we can take advantage of here that something like N-Service Bus does provide. We can actually move this back into being thread safe, and we can avoid that problem. Because if we look at these 2 operations here, what's happening is we're reading our week total out of the database, and we're writing our week total back to the database. We don't explicitly say, you know, DB connection, command, run, all the rest of it, but the infrastructure will do that for us. In this case, that's N-Service Bus. But we are also sending a message out. So we don't want that message to be sent if we don't do the discounting, and we don't want to do if we don't update the week total, and we don't want to update the week total if the message doesn't get sent out. We want that to happen atomically. And that is something that N-Service Bus guarantees. And if you're rolling your own solution, you'll have to do that too. There's for some queuing systems, you can make that happen in transactions. So if you're using, say, MSMQ as your queuing system and SQL Server as your database, you can wrap all of that in a distributed transaction. But if you're using almost any other combination of technology, that doesn't work. You need to implement something called the outbox pattern, which is a really, really difficult thing to get right. Luckily, N-Service Bus does that for you. And then what happens is either all of that fails or all of it succeeds. So If we imagine our 2 users clicking at the same time, 2 messages are going to get dispatched into the Saga. They're both going to look at the database, they're going to read out, and they're going to persist. They're going to try and persist the new state with the order. But what happens here is N-Service Bus will guarantee, using optimistic concurrency, that only one of these will succeed with messages sent, and the other will fail and the messages will not be sent, right? Everything has to happen atomically. So the order on the left will succeed and apply no discount, but add its total to the week total. The order on the right will fail. That message will go back to the queue and get retried. Again, this is something that N-Service Bus provides. That will get put back into the bus or back into the Saga by the infrastructure. This time it will succeed. It will read the new total out of the database that the other order updated. Its messages will be sent, and that will all succeed. So by using that consistency that the infrastructure guarantees, we've avoided that race condition. Our business is now happy. Our customers now happy. HTTP and things like that don't offer this, by the way. You need to be looking at something like a messaging infrastructure and guarantees of consistency. So at particular software, we are on a mission to kind of kill the batch job. We've seen too many instances of customers using batch jobs for these kinds of solutions where rethinking that arrow of time, turning that batch job kind of upside down and making it work with messages in the future and inverting it and having the consistency working that way allows you to do that. And if you want to know more about that, have a look at this blog. Again, take a screenshot, take a photo with your phone, whatever you need to do. Have a look at that in more detail in this blog post. Now, that's one way that's one way instance where we're tempted to use batch jobs, and we've looked at how we can get rid of that. But there are things, other things where you say, well, you know, I think a batch job really is the right solution here. So reports, for instance, someone may have you may be working with a system which generates some reports, and very often a batch job seems like the absolutely obvious solution to create a report. But the problem is they can be very costly. They can slow down your database, and they can actually take a long time to run, right? What is the night? I've worked in companies before where the overnight batch job has taken until lunchtime the next day to complete. And then you open an office in Singapore, you open an office in the USA, and all of a sudden you've got no night. But the thing about daily reports is they're interesting. What happens with a daily report? Someone might look at it at 9:30 in the morning and say, yeah, I look for large transactions in fraudulent countries over the past week, and then I report those to my manager. But how about introducing a Saga for that? How about every time there's a transaction coming through from a fraudulent country, you add that to your current week's fraudulent transactions, and you take it away in a week's time. And then when you see 3 of them, when any of those happens, you send a notification to your user. All of a sudden, your user is doing this real time. 1 minute after a transaction happens, they're notified that the week total has 3 transactions which might be fraudulent. They tell the manager, right? They no longer do it the next day at 9:30. They do it at 4 o'clock that afternoon when it happens. So very often, again, the report is a workaround. It's not a requirement. The requirement is something more like you see on the right. And I've got to tell you, managers find this mind-blowing, right? It's like, oh my God, I'm getting real-time business intelligence here. No, how do I get more of these Saga things? Where do I sign? And this is where you can actually transform your IT department or your IT team from being a cost center to being a profit center, right? This translates into actual business value. Your business can make more money. It can be more profitable by implementing these kind of patterns. I'm getting to the end of the talk now. If you want to find out more about this kind of pattern, look at it in more detail, again, take a screenshot of this URL. Follow this. I've actually prepared a free set of videos for you to look at in your leisure. This is from a multi-day course given by our CEO, a gentleman named Udi Hahn, and I hope you enjoy that and get more value from that. So I hope you've enjoyed this talk and I hope you found it useful. What I've tried to show you is rather than kind of patching things on using batch jobs and having stuff sitting outside your domain, you can actually fold those requirements into your ubiquitous language. You know, sagas are actually very good DDD aggregate routes, if that's your thing. They're actually also very good objects, right? Alan Kay, when he's first talked about objects, talked about something encapsulating state, getting messages in, sending messages out, right? It's actually a really good object. They're very testable. They're very nice to work with. So I hope you've enjoyed that, and I hope you enjoy the rest of the conference. And I am going to be online answering questions, so I hope to see you there. Bye for now. Thank you.
Hi, Adam.
Hey, Alex.
Can you hear me? Hi.
I can hear you. Can you hear me?
It's been a while. Oh, yeah.
It has. Yeah,
well,
good to see you.
Yes, last time we spoke, you mentioned traveling around in your van, your camper, all over Europe. And at the beginning of your session, you also referred to, well, you're an early inventor of the workation, I would say. Are you still doing it?
Absolutely, whenever I can. So I did mention I'm actually down in Portugal right now, so I do like to make use of the remote working facility. So I do try and move around as much as I can. I love it.
All right. Well, I think everyone enjoyed your talk. It's a very novel way of looking at, dealing with time-based logic. I really enjoyed it. There is a question from the audience. Let me just read it out to you. Somebody said, what is the best way to convince my team, and that being as a regular developer, not a lead, to adopt a more rational approach towards building our system, as you've shown in the presentation? Any convincing arguments that the person that asked the questions could use? How do you convince your team to take this approach?
That's a really interesting question. It's a very general question. It's kind of like I can paraphrase it as, how do I do things more better? How do I do things more nicely? The one bit of advice I would give there, I think, is don't try and change the world at once. I always advise against rewriting a system, right? That never really works. I would say do it bit by bit, take baby steps. I talked about the strangler pattern briefly in my talk. That's the way that I would approach things. Take something, for instance, if you want to introduce messaging into your system, take something which naturally lends itself to that pattern. So let's say you're going to send out a PDF to a user with a summary of their order. Take that out, send a message to do that, and do that in some kind of message-driven way that can be retried if things fail, and you can have a look at the queue and see that, oh, these requests to generate these PDFs failed. How can I retry them? Carve off little bits at once. And if you do that over time, that tends to build and build, and you get interest accumulating on that. And it could be a while, but all of a sudden, maybe a year or two later, you've discovered that, oh wow, we actually are doing things better. But I think that's the way. It's don't try and change everything at once. Take baby steps, chip away at the problem, and you'll get there eventually.
All right. Okay. Excellent. Well, I hope that is useful for them to start the conversation on this. Since there are no more questions, do you mind if I ask a question myself?
Go on then, fire away.
Oh, okay. So the thing you described also at the end with the object-oriented approach, an object containing state, receiving messages, sending it out, is also very much like the actor, and most actor frameworks do have this notion of remind and timers as well. How do you compare, the offering from NService Bus how does it compare?
Well, they are two. Those two patterns do have some kind of overlap. For me, the actor pattern is something more around kind of distributing tasks. It can be very useful for sort of scatter gather kind of activities. There was actually an interesting talk which I can try and find by Aaron Stannard, the creator of Akka.net, where he talked about actually combining the use of NService Bus or something like NService Bus with the actor pattern. So you can kind of use NService Bus or something like that and messaging queues to guarantee that something is going to take place, because that's what message queues are very good at. They're very good at saying, well, I'm not necessarily going to do what you're requesting now, but I'm going to write it down so that I know that I can do it later, right? That's effectively what you do with a message queue. And then you can use something like an actor pattern as a more tactical thing in order to actually get that stuff done when it's happening. So I'll try and dig that. I'll try and dig out that link and provide it for everyone, because that talks a lot more about that. But they're not necessarily alternative patterns that can be used in conjunction, and each has their own use.
All right. And what is your experience with event storming as a method, a type to figure out what the things are that are happening in the future, the events that you will put on into the future?
I think that's a technique which could be very helpful for this, because I always say that the difficult work is done not really when you're writing code. The difficult work is kind of done before that. It's about thinking about your business and talking to your business users and finding out from them what the requirements are. That's really where we add value as developers. If we get that right, the code that we end up writing tends to be very simple. I haven't written a lot of complex code for a long time. I do sometimes when I go into infrastructure. So, writing some of the stuff behind NService Bus, like implementing the outbox pattern, which guarantees a consistency between saving to the database and sending the messages. That can be very technically complex. But by talking to business users and figuring out the business requirements and doing the hard work there, which event storming can help out a lot with, that can actually help to make your code look very trivial. So I think it's a technique that can really help with this.
All right. Okay. Well, Adam, it looks like we're all out of time for any more questions. Do look at the Discord channel. There are some compliments on your session. We all enjoyed it, I'm sure, and I hope that we can meet again in person in some better time and place to discuss some more on all the things that you know about. So thanks for sharing, and have a wonderful day.
Thanks very much, Alex. I look forward to that too. Bye for now.